Near Saturn's north pole lies a geometric curiosity, a six-sided jet stream shaped like a perfect hexagon. This unusual atmospheric feature has puzzled scientists since its discovery, spinning steadily like a massive planetary snowflake. Saturn also spins quickly, completing one rotation in just over 10 hours. This rapid spin contributes to its extreme flattening more so than any other planet. Its equator bulges, the poles flatten, and the entire planet takes on a slightly squashed appearance like a spinning balloon caught mid-twirl dot from Earth. Saturn appears as a golden jewel in the night sky, distant and luminous. Even a small telescope reveals its famous rings, often drawing gasps from those seeing them for the first time. For centuries, Saturn has inspired wonder, poetry, and mythology. The ancient Romans named it after the god of time and harvest, a slow-moving world gliding across the sky with dignified grace. Yet for all its splendor, Saturn is a realm of silence. There are no cities, no sounds, no footsteps echoing in its atmosphere. Only ice, gas, gravity, and the slow ballet of moons circling it in timeless orbits. So as you lie back and rest, imagine drifting in Saturn's quiet. Picture the soft glow of its rings, the frozen haze of Titan, and the icy geysers of Enceladus stretching skyward. Saturn reminds us of the beauty, mystery, and quiet elegance of the faraway. Rest easy now. The ringed giant keeps turning silent and watchful, awaiting the next visitor to pause and listen. As we continue our peaceful journey outward from the sun, we reach a planet that seems to have ignored the usual rules, tossed the manual aside, and spun off on its own path. Welcome to Uranus, the seventh planet from the Sun, and arguably the most subtly rebellious world in the solar system. Like Jupiter and Saturn, Uranus is a gas giant, though more accurately an ice giant due to its higher concentrations of water, ammonia, and methane. It's a massive world, over 4 times wider than Earth, yet its oddity hides beneath a calm, pale blue surface. From afar, it looks peaceful, almost soothing. But there's much more beneath that gentle color. What stands out most is Uranus's extreme tilt. While most planets rotate with their poles roughly vertical, Uranus spins on its side. Its axial tilt is a dramatic 98, placing the poles where most planets have their equators. It doesn't just spin, it reclines. This leads to bizarre seasons. Each pole experiences about 42 Earth years of continuous daylight followed by 42 years of darkness. Imagine living in a place where summer spans 4 decades, only to be followed by a 40-year winter. Weather patterns here remain a mystery, but its unusual rotation definitely creates an alien climate. A day on Uranus lasts roughly 17 Earth hours, a fairly fast spin, especially given its sideways orientation. Still, the planet often appears featureless. Unlike Jupiter's storms or Saturn's bands, Uranus looks smooth and still, earning it the nickname the Bland Giant, an unfair label for such a unique world. Infrared imaging and seasonal studies reveal hidden activity, swirling storms, shifting clouds, and wind speeds reaching over 500 miles per hour. Its atmosphere contains thick layers of icy materials, including water, ammonia, and methane. Methane plays a key role, absorbing red light and reflecting blue and green, giving Uranus its signature pale blue hue. But beneath that gentle color lies intense pressure, freezing temperatures, and complex chemistry. Uranus is one of the coldest places in the solar system, averaging around minus 350 degrees Fahrenheit. It's colder than Neptune. Even though Neptune is farther from the Sun, the likely reason? Uranus emits very little internal heat, unlike Jupiter and Saturn, which radiate much more than they receive. Uranus also has a magnetic field, but true to form, it's unconventional. Earth's magnetic field is mostly aligned with its spin, but Uranus's is tilted 60 from its axis and offset from its center. It's as if the magnetic field is stumbling around, moving to its own rhythm. Now let's talk about rings. Yes, Uranus has them, though far less famous than Saturn's. These rings are narrow, dark, and faint, made of large icy chunks coated in an unknown dark substance. 13 rings are currently known, and more may exist. They were first discovered in 1977 when Uranus passed in front of a distant star, briefly blocking its light several times, evidence of the hidden rings. And then there are the moons, at least 27 of them. Unlike the mythological names used for most planetary moons, Uranus's satellites are named after characters from Shakespeare and Alexander Pope. There's Miranda, Ariel, Umbriel, Titania, and Oberon, each with unique orbits and features. Miranda is especially intriguing. A small, icy world marked by towering cliffs, deep valleys, and twisted terrain. Some cliffs drop 12 miles, among the tallest in the solar system. Its surface is so fractured and strange that scientists once joked it was assembled on a Friday. Ariel. The brightest moon is marked by canyons shaped by ancient geology. Titania and Oberon are darker, larger, and covered in impact craters and ridges. These moons are like miniature worlds, shaped by forces we're just beginning to grasp. Only one spacecraft has visited Uranus. NASA's Voyager 2 in 1986, during its flyby. It discovered Uranus's rings, its tilted magnetic field, and its peculiar moons. No missions have returned since. Most of what we know comes from telescopes and simulations. But that may change as plans for a dedicated orbiter gradually come together. Scientists hope such a mission will help unlock Uranus's secrets, despite its distance 1.8 billion miles. From the Sun and its slow 84-year orbit, Uranus has its own quiet allure. It's dim, distant, and often overlooked. But its calm surface, tilted axis, and whispering rings offer a silent, strange beauty. Uranus is a cosmic oddball, content to be different, moving through space at its own rhythm. So as you rest, imagine that soft blue world spinning slowly on its side. Let thoughts of tilted moons and icy clouds carry you across the cosmos. Far beyond the reach of sunlight, Uranus glides quietly, a dream in blue. Waiting to be known, moving beyond Uranus, we reach Neptune, the 8th and farthest known planet in the solar system. Cold, remote, and striking in its deep blue color, Neptune is a planet of wind, ice, and mystery. Orbiting nearly 3 billion miles from the Sun, sunlight takes more than 4 hours to reach its atmosphere. By the time it arrives, it's barely a trace, just a dim glow in a realm of frost. Neptune is another ice giant, like Uranus, made mostly of hydrogen, helium, and ices such as water, methane, and ammonia. Slightly smaller than Uranus, but more massive. It's the densest of the giant planets. If Uranus is the calm, reclining planet, Neptune is its darker, stormier twin world of energy beneath its calm face. Methane in Neptune's atmosphere gives it its rich blue color by absorbing red light. But Neptune's blue is even more vivid than Uranus's, and scientists aren't entirely sure why. It may be due to subtle differences in atmospheric makeup or haze particle size. Regardless, the result is stunning, a sapphire world glowing. In the dark, what makes Neptune especially fascinating is its weather. Despite its frigid average temperature of -375°F, it hosts the fastest winds in the solar system. Jet streams can exceed 1,200 miles per hour faster than the speed of sound. This is especially surprising given how cold and thin the atmosphere is. In the 1980s, Voyager 2 flew past Neptune and captured images of a massive storm system, the Great Dark Spot, roughly the size of Earth, spinning counterclockwise in the southern hemisphere. Unlike Jupiter's long-lasting Great Red Spot, Neptune's dark storms appear and disappear in a matter of years. These are high-pressure systems ringed by white methane clouds, swirling like whipped cream atop an invisible vortex. Voyager also discovered features like the scooter, a fast-moving cloud, and high-altitude methane clouds casting shadows below. All this activity makes Neptune feel dynamic, alive even though it exists far from the busy inner solar system. Neptune rotates in about 16 hours, a short day for such a large world. Like the other giants, it bulges slightly at the equator due to its fast spin. Beneath its clouds lies a slushy mix of water, ammonia, and methane ices surrounding a rocky core. It's not a surface you could stand on, just layers of increasingly dense, hostile material, but Neptune isn't alone. It has a faint ring system and at least 14 known moons, each unique. The rings are dark, dusty, and subtle compared to Saturn's, yet fascinating in their own right. Some of Neptune's rings are lumpy, with strange arcs that scientists think may be shaped by the gravity of nearby moons. The most prominent and intriguing of Neptune's moons is Triton, an unusual and captivating world. Triton is the only large moon in the solar system that orbits in the opposite direction of its planet's rotation, a movement known as a retrograde orbit. This indicates Triton likely didn't form alongside Neptune but was captured, possibly from the Kuiper belt. After drifting too close, Triton is also geologically active. When Voyager 2 passed by, it observed geysers erupting, plumes of nitrogen gas and icy particles shooting miles high into the thin atmosphere. The moon's surface is a frozen landscape of plains, ridges, and regions with a texture resembling cantaloupe skin, shaped by forces we still don't fully understand. Beneath this icy crust, there may be a hidden ocean, possibly kept warm by internal heat. Even though the surface remains extremely cold, because of its retrograde motion, Triton is slowly spiraling closer to Neptune. Billions of years from now, it may crash into the planet or break apart, forming a temporary ring system. It's a slow, gravitational dance unfolding over eons. Like Uranus, Neptune has only been visited by one spacecraft, Voyager 2. Its flyby in 1989 provided nearly all the direct data we have about the planet, and the encounter lasted only a few days. Since then, Neptune has been studied using powerful telescopes, but many of its features remain unexplored. In many respects, it is the most mysterious of the major planets, a giant whose full story has yet to be revealed. Despite its remoteness, Neptune holds a unique place in scientific history. It was the first planet discovered not by direct observation, but through mathematical prediction. In the early 19th century, astronomers noticed that Uranus's orbit deviated from expectations, hinting at an unseen force. French mathematician Urbain Le Verrier and English mathematician John Couch-Adams independently calculated the location of the unknown planet. When astronomers pointed their telescopes in that direction in 1846, Neptune was found gently shimmering on the edge of the solar system. A discovery born of careful analysis and curiosity, and perhaps that is Neptune's legacy, a reminder of how much we can uncover through patience, collaboration, and imagination. We've only glimpsed the surface of this icy world. Future missions may someday orbit Neptune, explore its many moons, and descend into its dynamic atmosphere. Until then, it remains a quiet, blue beacon in the outer reaches of our solar system, a promise of discoveries still waiting. So as your eyes grow heavy, imagine that distant planet spinning silently. Picture winds faster than sound racing across its atmosphere and clouds swirling over deep, unseen storms. Imagine standing on the frozen plains of Triton, watching the faint sun rise slowly, just a pale dot in a vast sky. Neptune is the last of the major planets, a quiet guardian at the edge of sunlight's reach. It speaks of remote places and stories not yet told. Tonight, it continues its slow rotation, silent, cold, and beautiful beneath a canopy of faraway stars, and so we come to the end of our calm journey through the solar system. 8 distinct planets, each orbiting the same star, yet shaped by different histories, forces, and timescales. From Mercury's scorched, cratered surface to Neptune's icy blue winds, every planet tells a story etched in rock, gas, and stillness. These are not merely distant objects drifting in space. They're reflections of what's possible in the universe. Some, like Earth, are familiar with oceans, forests, and breathable skies. Others, like Uranus and Neptune, feel alien, stormy, and glowing at the edge of reach. Yet all belong to the same family, bound by gravity, moving in quiet rhythms that stretch across days, decades, and centuries. And you listening here tonight are part of that same system. You are made of the same elements as the planets, moons, and stars. You breathe the oxygen given by Earth, warmed by sunlight that began its journey across space more than 8 minutes ago. You rest beneath the same stars that have watched over these planets for billions of years. Maybe this journey has brought you some peace. Maybe it even made you a little sleepy. If so, then I've done my job. But if you found it too engaging to fall asleep, I hope you still learned something, a quiet fact or curious detail to carry with you into your dreams. After all, the best kind of rest often begins with wonder. If you're still awake, I'd love to know, where in the world are you listening from? What time is it where you are? Are you winding down for the night, just drifting off? Or maybe listening during a peaceful afternoon, letting your thoughts wander among the stars? If you enjoyed this journey, this gentle exploration of our cosmic neighborhood, it would mean a lot if you tap the like button or subscribe to The Sleepy Scientist. There are many more soft-spoken adventures ahead, and I'd be glad to share them with you. But for now, close your eyes if you haven't already. Take a deep breath. Let the planets drift behind you like fading dreams. The solar system continues its graceful spin, and you are safely nestled within it, calm, small, and perfectly placed among the stars. Sleep well, traveler. Until next time.